microphone, so if I'm a bit loud, I'm sorry, because they sort of make me speak louder for some reason. I don't know why that is. So I'm Phoebe Stewart-Sinclair. I'm a new PhD researcher at UQ. I'm working there with Kerrie Wilson, Elisa Bayraktarov, and I've just come back to study, so it's a bit of a rude awakening. But what I'm really interested in the future is making a business case for proactive restoration. So for me, I see that there is a real opportunity to use restoration, coastal restoration, not just corals, as a management tool for climate change, so to increase resilience of the coast. So we know that corals are really good as a form of coastal protection, and so are shellfish. We know that mangroves, salt marsh and seagrasses, they store carbon, blue carbon, and that can be used to offset emissions. So that's really what I'm interested in the long term. And today what I'm going to be talking about is the database and the data that I'll be using to build this business case. And if you think my data's a bit crap, please give me yours. So that's my first thing I'd like to say. So we know that coral reefs are declining, we all know that. What we're really interested in is asking the questions, what's the cost of coral reef restoration? Is it successful? How do we define success? What scale are we operating on? Is it scalable? Is it feasible at the current costs that it is? And does investment in coral restoration, so doing expensive techniques, does that lead to increased success? So these are the questions that we were asking, and ecologists in general, and I'm one of them, we're really crap at reporting on costs and the economics of our projects. So it's really hard to make a business case for something if you don't have an idea of the risks involved, the uncertainty factors, and how much it's going to cost you. So we're in the era of restoration. What we did is we looked at grey literature, primary literature, practitioners in the same way that Elisa did, but we filtered this for studies that reported on cost and survival. So we use survival as our measure of success, not because we think it's a good measure of success, but because the studies that did report on cost, most of them reported on survival as their measure of feasibility of their study. So that's what we use because that's what's reported. And I definitely agree with the previous two speakers that measuring survival is not necessarily a good indicator for success, but that's what we've got so far. So I've got 5 databases for 5 ecosystems, and this is built on a database that Elisa Bayraktarov started and published in 2016. It's definitely not a perfect database by any means, and we would love to add to it. So what we found is that coral is definitely the most expensive ecosystem to restore, and mangroves are the cheapest. And I'd like to say a few things about these cost estimates. First of all, they're median estimates, which we used median because there was so much range in the data. The other thing is that these are likely underestimates. The reason for that is that when costs are reported, they often just report how much it costs to set up a nursery, how much it costs to transplant fragments. So they're not total reported costs. You can see that mangroves is a lot cheaper than corals, and again, that's not necessarily accurate. So mangrove restoration tends to have huge bodies of volunteers who are not paid, and the labour that they put into that is not incorporated into any cost estimates. So these are all likely underestimates. In terms of looking at coral restoration alone, the most expensive types of restoration were sexual proliferation in the lab and nurseries, ex situ, and restoration efforts that followed a ship grounding. So those huge ecological disasters from ship groundings went up into the millions of dollars per hectare. I generated this plot which breaks down a few of the categories that Elisa's using. So you might notice that our talks very almost overlap, and we noticed that too, so we're working together now. And you can see that coral gardening, I don't know, hopefully you can see that. You can see that coral gardening is quite high, and that's because these estimates include outplanting, and at the moment we haven't separated out sexual reproduction from asexual reproduction. So sexual reproduction tends to be a lot more expensive than asexual, and we really need some more information on whether or not it's worth that extra investment. So what is the scale of coral restoration compared to other coastal restoration? Is it worth it for coastal protection to do coral restoration as opposed to oyster restoration? I know that's a potentially controversial thought, but that's the kind of thing that investors are thinking about. And we can see here that coral reefs, the median area restored was 0.003 of a hectare, so that's 30 metres squared. And I think that is mostly because these are pilot studies that want to be scaled up. But when you scale it up to a hectare, we have a median value to 2018 of $400,000 per hectare. And that's not scalable. So we really need to be working on feasible ways to scale this up. In terms of project duration, I'm talking about this mainly because it relates to my next point. So most restoration lasts for 1 or 2 years. The median time for coral restoration is 1 year for the studies that we looked at. And that means that our estimates of success, which I'm going to talk about next, are over 1 year. So our estimates of success are likely an overestimation, as survival is likely to decline into the future. So I 100% agree with Margot that there needs to be some monitoring done. The other thing is that a lot of times the restoration is done for increased biodiversity or increased ecosystem service functioning, but none of that is measured. So survival of restored organisms, this is, like I said, is over 1 to 2 years, and you can see that that corals actually had the best survival of any of the ecosystems that we looked at. And I think that that's important to note, but they're also the most expensive. So when Elisa published her review in 2016, she noticed that there was a real bias towards publications that had high survival. So basically, her hypothesis is that if you spend a lot of money doing coral restoration and nothing survives, you're unlikely to publish that. And when she had a look at her data and had a look at a histogram like this, she found that there was a real skew towards the right-hand side, so skew towards successful restoration projects. I've updated this, and we don't really find that anymore. So I found that once we've added 4 years worth of data in a time when the world is really interested in coral restoration, there is much less bias towards successful operations. And what that's done is that our survival estimate for the average survival of corals has gone down, and I think it's becoming more accurate. The other thing that we wanted to know is that, is it really worth it? Because this is the beginning of our economic investigations. And so we tried to look at whether doing expensive interventions, so the cost of an intervention per hectare, was correlated in any way with success as measured by survival. And we found that expensive interventions are not necessarily worth it at this stage with the data that we have. And so the dots on this graph, each one is a study that reported on both cost and survival. And in 40 years worth of data, there's not that many dots on there. And so my plea to practitioners is that if these estimates look shoddy to you, please answer my cost audit that I'll be drafting in the next couple of months, because I would love for these to be more accurate. So our conclusions is that coral restoration at this stage is expensive. It's done on a really small scale, and the cost of it is not scalable at this time, and spending more is not necessarily worth it. We found that corals were the most expensive ecosystems to restore, but they were also had the highest survival of all of the ecosystems that we've looked at. In general, these projects are really short-lived, so we don't know about the long-term feasibility of these projects, which is a real problem if you're trying to make a business case, because there's a very little idea of the risk involved. We also found that success, as measured by survival, was not dependent on the money that you put in, and instead it was dependent on ecosystem type, site selection, and technique used. So that's really interesting, because I think that means that there is, that it makes it a good investment if we can go for cheaper options that are going to work just as well. The other thing is that we use survival here as a measure for success, but it's not a very good measure. Other really prevalent measures were things like cover and density, but we really need to start looking at more ecosystem-wide indicators to measure success. And finally, just another plea that if you disagree with any of these values, like I didn't make them up, please give me your data. I would love it. I really would just like to re-emphasise some of the themes that we've talked about this week. So I wrote these before I came, and I've added a few little acknowledgements there. So scaling up, I think, will require joint efforts. We really need to get industry on board. There's only so much of the public taxpayers' dollars that can be used to invest. That was talked about this morning. The other thing is that coastal ecosystems provide huge values in terms of ecosystem services, so they're really good investments. And I think that we need to be talking to business and industry in that way. I think that innovation is necessary, because at the moment interventions are so expensive, and so I've put a little note in there for RRAB, because I think what they're doing is amazing and necessary and timely. And the last thing I'd like to say is that what we're interested in doing is doing a bunch of cost-benefit analysis to prioritise where, what, how much to restore. Like, for example, 50 Reefs project that just published last month. So give me your data, that'd be great, and thank you for listening.